Hello, and welcome to Backer Breaks It Down. In this episode, we continue to explore the graphs of sine and cosine functions. Together, they're called sinusoidal. I know, that's a funny word, huh? Okay. So previously, we focused on amplitude, period, and midline, just those. Okay, but let's talk about some other things, okay? So we can model periodic phenomena using transformations of the sine and cosine functions, and we call these sinusoidal functions. So notice that our function formulas have gotten a little bit longer. Okay, so A and B, we are familiar with the values of A and B. A, the absolute value of A is your amplitude. B can be used to find the period. So we go 2 pi divided by B, and that tells us the period. So the length of one cycle in the graph. And then, of course, K, like we talked about midline, right? Y equals K is the midline. It also represents a vertical shift. So if it's plus K, it's up, minus K, it's down. Now, H is representing a horizontal shift. So for like T minus H, that's a movement to the right. T plus H is a movement to the left. Okay. So with these functions, there's something called a phase shift and a horizontal shift. Okay, I'm just gonna go here. All right, so here I'm seeing a cycle of sine. And like when I look at the graph, what I see in the graph is I see a horizontal shift of pi over 3 to the right. Okay, because sine usually starts right here, but this one has been shifted pi over 3 units to the right. In the function formula, I don't see pi over 3 at all there. So inside the parentheses, I have 2x minus 2 pi over 3. Okay. So the horizontal shift is like what I see when I look at the graph. Okay. In my function, it's not like when it's written like this, it's not as clear. Okay. So what is that 2 pi over 3? Well, that 2 pi over 3 is the phase shift. Okay, so we're just going to analyze it as the phase shift. So I would say there's a phase shift to 2 pi over 3 to the right. The horizontal shift is what our eyes see, and that horizontal shift of pi over 3 can be obtained by taking what's inside the parentheses, 2x minus 2 pi over 3, and factoring out that coefficient in front of the x. So if I take out that coefficient of 2 and I write down what's left over, I have x minus, and then 2 pi over 3 divided by 2 is pi over 3. And there is that horizontal shift that I see. Okay. So going back to the previous slide, okay, phase shift versus horizontal shift. So our eyes see the horizontal shift when we look at a graph. Okay, so the horizontal shift can easily be identified if we factor what's inside the parentheses. So basically, if there is a coefficient in front of like the input variable, in this case it's t, if I factor it out, I can then identify what the horizontal shift is. In its non-factored form, that b times h is your phase shift. Okay, so we're just going to like analyze and identify phase shifts, but we're not really going to see them in our graphs. Okay, we got to do some factoring. So, but let's just focus on analyzing. So here we have two functions. We want to analyze them for their period, amplitude, midline, vertical shift, phase shift, and horizontal shift. So let's start with the ones that don't require us to do any math, right? So the 2 tells us our amplitude, right? The minus 1 tells us two things. It tells us our midline is y equals -1, and it tells us a vertical shift. Being -1, that means it went down 1. And then something else I know without doing any math is the phase shift. because in its non-factored form, 2 pi over 3 is my phase shift. And since it's plus, that means it's going left 2 pi over 3. Okay, that we won't see that in the graph of the function. What we will see is the horizontal shift. So let's factor now. So I'm going to take out the coefficient to the x term. So that would be pi. And then I'm going to write down what's left over. So what's left over is x plus 2/3. So that plus 2/3 is a horizontal shift to the left, 2 over 3. And then, of course, the period. Remember the period, we have to do math. We have to go 2 pi, because that's the normal period, divided by the b value. So in this problem, we're going 2 pi divided by pi, so we simply get 2. Right, so we'll start by identifying things that are easy to identify simply by looking at the function in its given form. So in number 2, since a is -4, my amplitude is +4. The amplitude will always be positive. This +2 tells me 2 things. It tells me the midline is y equals 2, and it tells me that there's been a vertical shift up 2. And then this -7 pi. Minus means it's going to the right. Yikes. Seven pi units. Sorry, I don't know why this isn't working. So right 7 pi. For the horizontal shift and the period, we need to do some factoring. So we need to factor out that coefficient. So that's 2 comes out. X minus 7 pi over 2 is what stays in. So what that tells me is that my horizontal shift is right 7 pi over 2. And the period, do the period math, 2 pi divided by that b value. So 2 pi divided by 2 is what I'm doing here, and I get the period as pi. This is like really messy. I don't know why my stylus isn't working. Sorry. Right. But that's how we can like analyze the function formula for a sinusoidal function, so sine or cosine. So the rules for like amplitude, period, and midline are still the same. The midline also tells us about a vertical shift. And then in the non-factored form, we can identify the phase shift, and then we factor out that coefficient. And when it's in that factored form, then we can identify our horizontal shift. And that's how Becker breaks it down.